Hello everyone, welcome back to my YouTube channel. In this particular video, we'll be looking into what is the concept of skewness and symmetry. In skewness, we have some types. For example, left skewness, right skewness. We are going to look into all of them one by one in this particular video. So let's first understand what exactly it means. So skewness and symmetry are the two concepts in statistics that describes the shape of the distribution. Just mark these words, shape of the distribution. It describes how your data is actually oriented in a 2D manner. So here is an example of a distribution of a data. Here we have considered only a single variable, or I would say a single data column. This is the distribution. You can see how the data values are actually oriented. It can be clearly seen with this particular distribution. Now, what exactly is the significance of this? What this particular distribution is called as? We are going to look into it next. So, let's see first what exactly symmetric distribution is called as. It might consist of some symmetry. So here you can say that a symmetric distribution has same shape on both the sides of the center, or rather the mean. So we already have seen how to calculate the measures of central tendency. One of the measure of central tendency is mean. So whenever we plot the distribution and whenever we calculate and mark the mean of that particular distribution, taking that mean as a center point, or I would say as a point of consideration, if we have the same shape on both the sides of the mean, for example, the left and the right, then in that particular case, it is called as symmetric distribution. It is also called as zero skewed distribution. Now, just remember, symmetry and skewness both are opposite. If there is zero skewness, then in that particular case, it is purely a symmetric distribution. Now, let's have a look at a simple example of this particular distribution. So over here, you can see that this is the distribution. Here are the mean values and here is the maximum value in this particular distribution. Now, when we plot the mean of this particular distribution, which comes over here, you can clearly see that to the either side of these, that is to the left side and also to the right side, you can see there is a symmetry in distribution. You can see the distribution goes like this. Same way here also the distribution goes like this. So it has a bell shape, or it is also known as Gaussian distribution. So this type of distribution where there is a symmetry on either side of the mean point, it is called as symmetric distribution. So there are some terms which describes this type of distribution. One of them is bell shape. Second is normal distribution. Now, whenever your data is in the form of normal distribution, this normal distributed data will always be more useful as well as helpful. And this normal distribution is also known as Gaussian distribution. So I hope all these three names of this particular symmetric distribution is clear to you all. Now, there is a speciality of this particular symmetric distribution. We already have seen the mean point comes at the center. Now, if a particular distribution is purely normal, or I would say purely symmetric, then in that particular case, the mean, width, median, and mode are at the same point. In simple terms, always remember a symmetric distribution will always have same value as mean. The same value will be the median, as well as it will also be a mode. So just remember this particular special point related to symmetric distribution. So I hope the symmetric distribution is clear to you all. Now let's move on to the next type of distribution, which is called as skewed distribution. Now let's see what exactly is this skewed distribution. You can see that a skewed distribution is the one that is not symmetric. I already told you that symmetric and skewness, both of them are opposite. Whenever we have a skewed distribution, it is always be a non-symmetric distribution. Now, this skewed distribution will be having a longer tail on one side of the center than the other. That means it won't be having any symmetry with respect to the mean point. One of the side of that particular distribution will be consisting of more number of data points, which will lead to a longer tail on the other side of that particular distribution. Now, mean, median, and mode in this particular type of distribution are not at all equal at any cost because it is a non-symmetric distribution. Now, a simple example of skewed distribution is exponential distribution. If you look at the graph of this particular exponential distribution, you will come to know that it is not symmetric. It has a longer tail on one side. Now, as I already told you that skewed distribution is having some types, for example, left and right. Now, let's have a look at these types. Do you want to check out this attractive funny memes? Then what are you waiting for? These are just a glimpse of the memes that I've created on my Instagram page. You can find the link to my Instagram handle in the description box. Please visit the link and do watch all these interesting funny memes. These are not just memes. These memes and reels contains technical information. Here I try to relate memes with the technological concepts. So please do appreciate that by watching all those. And if you love it, please hit the follow button. First, let's have a look at the left skewed distribution. So, this left skewed distribution is also known as negative skew. Remember this point because this particular thing will be useful whenever we have to figure out the type of distribution with the help of some ways, which we are going to look in the upcoming videos. So left skewed distribution is also called as negative skewed distribution. So let's see what exactly it is. So as I already told you that skewed distribution will be having a longer tail on one side. Now in this particular left skewed distribution, it will be having a longer tail on the left side of the center or the mean. Just remember this point, it will be having a longer tail on the left side. That is why it is called as skewed distribution. Now the data values are going to be more concentrated on the right side. Now you just imagine if the distribution is having a longer tail on the left side, that means there will be lesser number of data points on the left side, which will create a condition where there will be more concentration of data points present on the right side. There will be a bulk of data points present. We will see one example through which the left skewed distribution will be clear to you all. Now, the example contains the condition as the age at which people die in developed countries. So now, just pause the video and try to imagine how the graph will look like. Here we have to plot the age on the x-axis. X-axis will contain the age and y-axis will contain the count of people who are going to die at the particular age. Now you just think that here the age will be 0. There will be lesser number of people dying at this particular age. If we go ahead, we'll be having increasing number of ages here. So obviously, if the age is increasing, there will be high chances that the person will die. So that is why the graph will look something like this. So the distribution will look something like this. So let's have a look at the distribution. You can see over here, we have this distribution where the age is starting from 0. The number of people who are dying at this particular age in developed countries are obviously lesser in count. Whereas if we compare at this particular point, this is the age where more number of people die. So you can see as the number increases, as the age increases, there are high chances that people will die. So this is a left skewed distribution. Why it is called as left skewed? You can see that on the left side of this particular distribution, we have a longer tail. Whereas on the right side of the distribution, we can see that we have more number of data points present. The concentration is high. So that is why this is called as left skewed distribution. It is also termed as negative skew. I hope it is clear. Now let's move on to the next type of skewed distribution, which is called as right skewed distribution. Now, right skewed distribution is also termed as positive skewed distribution because the skewness value at this particular situation will always be positive. Now, here in this particular case, it will be having a longer tail on the right side of the center or the mean, which is exactly opposite of the left skewed distribution. Since this type of distribution is having a longer tail on the right side, there will be more number of data points or the concentration of data values will be more on the left side of the distribution. There will be a bulk of data points present on the left side of the center or mean. Now let's have a look at the example of this particular distribution. You can see this particular plot. Over here you can see how the distribution goes. It has a longer tail on the right side. That is why it is called as a right skewed distribution. And on the left side, you can see the concentration of data points is comparatively very much high when we compare it with the right side. That is why this is called as a right skew distribution. it will always have a positive skewed value. So now I hope the types of distribution, left skewed, right skewed, and symmetric distribution is clear to you all. Now let's have a look at the different ways through which we can find out the measure of skewness. Now, why we find out the measure of skewness? We find out the measure of skewness to understand the type of distribution that particular variable will be having. There are multiple ways. I have listed three ways through which we can find out the measure of skewness. First is Carl Pearson's coefficient of skewness. This is the very popular way through which we can find out the skewness value. Second is Boole's coefficient of skewness, again a popular one. And the third is Keely's coefficient of skewness. So these three are the ways that I have listed through which we can find out the measure of skewness. And because of this measure, we can understand the type of distribution it has. In the upcoming videos, we are going to look into some of the ways through which we can find out the skewness measure. So stay tuned for that. Remember always, if the skewness value is positive, then in this particular case, it is a right skewed distribution. If the skewness value is negative, in this particular case, it is left skewed distribution. And if the skewness value is zero, if the measure is zero, then in that particular case, it is a purely symmetric distribution. So I hope you will remember this particular things. In the upcoming videos, we'll try to cover all these ways through which we can find out the skewness. So I hope everything is clear in this particular video. If you like this particular video, then please like, share and subscribe to my channel. Also hit the bell icon and don't forget to follow me on Instagram. Please join me on Telegram and thanks for watching. Have a good day ahead and stay tuned for the upcoming videos.